Okay, good morning, class. So at this point we're looking at the Sansuzi cycle test 1 of 2020. Okay. So it's the grade 12 cycle test 1 of 2020. Okay, this thing is not charging, so I just hope it doesn't switch off while we're teaching. We're still busy with the paper. Okay. So let's go. It was a 1 hour paper for 50 marks. Show all working. So coming to question 1.1, it says prove the sum of the arithmetic sequence. Prove that the sum of the arithmetic sequence is given by the formula. You guys know how to prove the formula, not so? In the description box below, you'll find a link to the proof of the arithmetic, and in that video you'll find the geometric formula as well. Okay, if you forgot how to do it, it's worth 4 marks there. Okay, so that link to that will be found in the description box below. Right, so let's look at 1.2. In question 1.2 it says, consider the sequence, and the sequence is 3, 1, 3, 2, 3, 4, 3, 8 and so on. It says write down the next 2 terms in the sequence. Okay, so if you are seeing every second number is a 3, so there is going to be a 3. Okay, as you can see you've got 1 to 2, we multiply it by 2. Can you see that, people? So if I multiply 8 by 2, I'm going to get 16. So the answer there is going to be 3, and 16 is the next 2 terms in the sequence. Okay. But note at this point, it's a 2-in-1 sequence. Can you all see that, people? It's in that time of the day. So you're not charging. Right, so let's look at the next one. It says calculate the sum of the first 20 terms of the sequence. So what do you notice here? Half is going to come from one, and the other half is going to come from another part. Can you see that? So you got the sum of 20 terms. Of course, it's going to be 10 threes. Not so. You got 3, 3, 3, 3, 3, 3, 3. Now yesterday some of you came up with, you saying if you got 3, 3, 3, 3 as a sequence, then you use the geometric progression as the sum of. Not so. But there was a condition when you worked out the sum of n terms. Okay? For the formula a r n minus 1 over r minus 1, r can never be equal to 1. And then, but you said r was 1. Can you see that, people? So, as you can see, the easiest way to work out that 10 threes is 3 times 10. Plus, if you look at this part of the pattern, which is 1, 2, 4, 8 and so on, we know it's geometric pattern, not so? What is the formula? Sn is equal to a r n minus 1 over r minus 1. So your a value, of course, is 1, r is 2, because I'm multiplying it by 2. And 10 will come from this pattern. Not so? So it's going to be 2 to the 10 minus 1 over 2 minus 1. From here, just put it in the calculator. Is somebody following the memo? No? So it's going to be 30 plus. You don't have to break this apart. So it's 2 to the exponent 10 minus 1. It's going to give you 1, 2, 3. Which is going to give you 1, 0, 5, 3. Is that correct? Yes, sir. Okay. I don't know what is the problem now. Okay. Let's carry on with our lives. In 1.3, so that was 1.2 years. 1.3 says, this is paper from our school. the St. Susie Girls High School. Okay. Alright, the first three terms of arithmetic sequence. So here we are told it's arithmetic. So I can only use arithmetic formula. Okay? So that of course is term 1, term 2, term 3. Okay? 3x, x minus 1 and 1 minus 2. Solve for x, hence calculate the value of the 16th term. So first I need to solve for x. So it's arithmetic, but exclusive to arithmetic sequences, it has a common difference. So it's going to be T3 minus T2 equals T2 minus T1. Okay. So importantly here, we know that T3 is going to be 1 minus 2x minus x minus 1 is equal to x minus 1 minus 3x. I didn't need the bracketing. It's going to be 1 minus 2x minus x plus 1 is equal to x minus 3x is negative 2x, of course, minus 1. Since it's a linear pattern, I'm going to take x is one side, numbers the other side. Of course, that cancels. So I got negative x is equal to minus 3, so x is equal to 3. You all agree with that? So the first three terms of the sequence, of course, is going to be 3 times 3. And then it's 3 minus 1. I'm using this now. And 1 minus 2 times 3, which is 9, 2, and negative 5. Is that correct? In other words, I'm subtracting 7 all the time. Not so? So it's minus 7. So this question 1.3. So that would simply be, what did they want? The 16th term. The Tn is equal to a plus n minus 1d. So T16 is going to be 9 plus 16 minus 1 is 15 times 3, which is negative 7. So you plug that in the calculator, so it's 1 plus 15 times negative 7, then the answer negative 96. Is that correct? Huh? Any problems here? No? Okay. So if this was the test, you would have gotten full marks. Okay. I don't know why I put the B there, but okay. Right, so let's carry on with the lives. We are told that in 1.4 the sum to infinity of a geometric sequence is 27. The sum of the first three terms is 35. Calculate the constant ratio. So in other words, we're calculating R. Okay. So the sum to infinity, so S infinity is equal to A over 1 minus R. Is 27. Okay. Then the sum of the first three terms, so S3, so firstly Sn is equal to A R n minus 1 over R minus 1. So S3, the sum of three terms, is going to give you A R cubed minus 1 over R minus 1 is equal to 35. Okay. So this is equation 1, and then we can simplify this a bit. So it will be A, I'm going to take the difference of cubes there. The difference of cubes will be R minus 1, square the first term, positive, R times 1 is R plus 1, we've done this in grade 10. R minus 1 is equal to 35. So of course that cancels. So we have A into R squared plus R plus 1 is equal to 35. I could divide both sides by the bracket of R squared plus R plus 1 if needed. Okay, but I'm not going to do it at this stage. I'm going to call this equation 2. On the other hand, if I look at this here, okay, so what I'm going to do is I'm going to make A the subject of the formula here rather. So I cross multiply, so A is equal to 27 into 1 minus R. This is equation 1 and this is equation 2. So what I'm going to do is I'm going to substitute equation 1 into equation 2. This is question 1.4. Alright. So now, wherever I see a, I replace it with 27 into 1 minus r times r squared plus r plus 1 is equal to 35. Okay. So I'm going to multiply this in here. Okay. So it's going to be 27. If I swap this around, the negative comes out. Then it takes me back to what I had, not so, which is this here. So I multiply the first and the last, so it's negative 27. R cubed minus 1 is equal to 35. So I divide both sides by negative 27, so r cubed minus 1 is equal to 35 over 27 in the negative. You take 1 over, it becomes plus 1. So I'll have 1 minus 35 over 27 gives you negative 8 over. So r cubed is negative 8 over 27. The cube root thereof is negative 2 over 3. Okay, that's a very good sum. I think it was like 5 marks or something. Yeah, 5 marks. Was that correct? Right. Then of course you must get the sigma sum. It says calculate without the use of a calculator the value of. Whenever you're going to be given the sigma sum, where do we start? We start by the constant. We first work out the first 3 terms. I don't know why these guys. This here the thing goes off before we finish. Alright, so we first work out the first 3 terms. Okay. So it's going to be, we start with r is 5. So it's going to be half into 99 minus 3 times 5 plus half. So then we go to 6. So it's 99 minus 3 times 6 plus half times 99 minus 3 times 7 and so on. Okay, those are the first 3 terms of the sequence. Okay, so I'm just going to simplify this a bit. So that's going to be half into 99 minus 3 times 5, which gives you 42. Okay, plus, now what changes there is that number, it becomes 6 now, 81 over 2, plus the next one, it's going to be 7, it's going to be 39. Not so. So how do I move from one term to the next? You're minusing 1 and half. You all agree with that? Because that 41 over 2 can be written as, 81 over 2 can be written as 40 and half. Not so? Or 40.5. So coming back to the question, we must calculate without using the so what does sigma stand for? It's in the sum. So how many terms are here? We got the starting point, 30. The ending point, minus starting point, plus 1. So your ending point is 25, minus 5 plus 1, which is 21. You all agree with that? So in other words, I'm working out the sum of 21 terms. So S21 is equal to, firstly, Sn, you do that first. Sn is equal to n over 2 into 2a plus n minus 1d. So you'll have S21 is 21 over 2 into 2 times a, which is 42, plus 20 times d, which is negative 1.5, or negative 1.5. Okay. We plug that in the calculator, so it's 21 over 2 into 2 times 42 plus 20 multiplied by negative 1.5. That gives you 567. Is that correct?
Yes, sir.
567. Okay. Any confusion here? Okay. Looks like nobody did their homework.
Yes, sir.
Okay. That's why I said, I didn't say nobody did it. I said looks like. My looks can be, but I look around. Okay. Alright. So given the sequence, you got 3, 6, 9, 12. Sorry, 3. Then we got 6 sine x. Then we got 9 sine squared x. Then we got 12 sine cube x. What you should notice here, that how do I move from one to the next? From 3, 6, 9, 12. So here I'm adding 3, not so. Okay. So the general term for this is simply going to be Tn is equal to a plus n minus 1 d, and it's going to give you 3n. So for this part, it's going to give you 3n. You see it's a 2-in-1 sequencing. For the signs, remember now there's a 1. Yes. So there's 1 sine x, sine squared x, sine cube x, and so on. So the general term for this is going to be Tn is equal to a or n minus 1. Not so. What's my a value? 1. So it's going to be 1. R is going to be sine x. As we move from one term to the next, you're multiplying it by sine x. So it's going to be sine x raised to the power n minus 1. Or I'm going to write it like the sine x raised to the n minus 1. Okay. But remember it's 2-in-1. So therefore the general term of this sequence is firstly going to be 3n times sine x raised to the power n minus 1. Okay, that's your general formula then. Then in the next question, it says calculate n if Tn is equal to 96, sorry?
For 1.6.1, the general term, why is it 3n times sine x?
So look at the original sequence. Is this not 3 times 1, 6 times sine x, 9 times sine squared x, 12 times sine cube x? Is that not? That is why I'm going to multiply. Make sense? Alright. Just coming back to this here, to numbers 1.6.2, it says calculate the value of n if Tn is equal to 96 sine 31 to the x. So what is Tn? Tn is 3n times sine x raised to the n minus 1 is equal to 96 sine x raised to the 31, in other words. So I can do one of two. I can either say sine of x raised to the n minus 1 is equal to sine of x raised to the 31. Not so? Is the basis the same? Yes, so the exponents are equal. So n minus 1 is 31, so n is equal to 32. Or you could have said 3n is equal to 96. And then divide by 3, I still get 32 on your n value. Okay. So therefore the 32nd term is equal to 96 sine to the 31 of x. Okay. Then I want you to know, give in 1.6.3, they want you to work out T100. So T100, again that's my formula, that's it. Tn. So it's going to be 3 times 100 times sine x raised to the 100 minus 1, which is 99. So it's going to be 300 sine 99x. Okay. That was fairly simple there. Okay. 1.7. In 1.7 it says the common difference of an arithmetic series is 4. So what is 4? The common difference, which is D. The question says prove that 2n is equal to the square root of Sn is 2n minus 2 times Sn. Okay. So this is an identity. So we must prove left hand side equal to the right hand side. So which side is more complex? The right side. So you start the right hand side. Okay. As we do in 3. No? So Sn is what? N over 2 into 2a plus n minus 1. Otherwise, Sn is also n over 2 into a plus l. So since I don't have the last term, am I going to use the second formula? No. So what we do is we go with the first one, but what is d now in this case? D is simply 4. So I'm going to replace d with 4. If you look at S2n, what changes? The n, so it will be 2n over 2 and 2n minus 1. That changes. Why? Because now I'm using S2n. Are you all okay with that, people? Does I write it out for you here? No, okay? So, we go the square root of S2n is exactly what we just mentioned now. Let's pull this down a bit. Whoops. What do you mean? Pull this down. Okay. So that's going to be too small. Then we go the square root of. Right. S2n will be now 2n over 2 into 2a. Do we have a? No. So it's 2a plus. What is n now? 2n minus 1 times d, which is 4. Alright, so that is S2n. Minus 2 times. Now Sn is exactly this here. So it's going to be n over 2 into 2a plus n minus 1 times d, which is 4. So that's closed and this is closed. Alright, so from here it's just a matter of simplifying. Okay, so we got the right hand side. 2 cancels 2. Not so? So that will be the square root of n into 2a plus. Get rid of the inner bracket. So it's going to be 8n minus 4 minus, of course, the 2 and the half cancel. So it's going to be n into, multiply that in, I get 2a plus 4n minus 4. Okay, you all agree with that? Right, so what do I do now? Get rid of the inner bracket, not so? So that is going to give me the square root of, this is now gone, taking that out, I don't need it anymore. So it's 2an plus 8n squared minus 4n minus 8an minus 4n squared plus 4n. Right, so what happens now? Simplify. Okay, cancel where we can. I made a mistake somewhere. Supposed to have been 1, 2, 3. It's supposed to have been 2an. Not so? Because when I multiply that out, I don't know, I've got that 8. But anyway, that cancels, not so? And this cancel. Which now leaves you with the square root of 8n squared minus 4n squared is 4n squared. Not so? What's the square root of 4n squared? 2n. Which is also equal to the left hand side. Okay. And there we go. Nice sum. So worth every one of those 5 marks. People, the section of work you haven't done yet, but for the video purposes, I'm going to explain it anyway. Okay. So in number 2, you are told given, you got m of x equal to negative 2x squared. This forms part of the functions and inverse functions which is taught in grade 12. Right, so sketch the graph of m and its inverse relation on the same set of axes. So to draw the negative 2x squared graph with the x and the y, you go minus 1, 0 and 1, gives you negative 2, 0 and negative 2. So if I draw that graph, you got the y and an x here. So you have 0 and 0, which is the center point there, negative 1 and negative 2, which is this point here, and of course 1 and negative 2. Okay, at least 1 point you must write on there on your graph. So that is m. So when we look at the inverse function, we interchange your x and y values. Okay, which means to say your inverse function, you will take your inverse relation because it's not going to pass the vertical line test. So So for the inverse function, we interchange x and y. So we got x and a y. So minus 1, 0 and 1 becomes minus 2, 0 and minus 2. Taking that into account, 0 and 0 remains 0 and 0. 1 and negative 2 becomes negative 2 and 1, which is approximately there. And then negative 1 and negative 2 becomes negative 2 and negative 1, which is approximately there. So I'll write this in, negative 2 and 1. Again, just normally write 1 point in there, and that is your inverse function. And remember, the inverse function is always reflected in the line y is equal to x. Okay, so that gets you 4 marks. Then the next question says, write down the domain of the inverse function. Okay, in this case it's a relation, but the question is with regards to the domain. So the domain is all possible x values. As you can see here, does this graph exist at negative infinity? Does the inverse exist at negative infinity? And the answer is yes. As you can see, it's going to negative infinity. But it stopped existing at 0. So for the domain of this graph, we need to say x has to be less than 0. Okay. Does it exist at 0? Yes. So x is less than and equal to 0 in that case. In 2.3, the question says, restrict the domain of M in one way so that the inverse of M will be a function. Okay, the paper will be found in the description box below. Okay, I'll put the link to this paper in the description box. Okay. So as you can see here, that the inverse is not a function. Why? Because it does not pass the vertical line test. However, if I only take this part of the graph, into account, okay, which is 0, if I only take that part of the graph in account, definitely I will pass the vertical line test, as you can see. We will cut it at one point only at any part in the graph. Okay. So if this is, let's take that into account. Your vertical line, as you can see there, will cut at 1 point only. Here it didn't cut, it cut more than 1 point. So that's what makes this not a function. However, because it cuts at 1 point only, it will be a function there. Otherwise, if you take the negative into account as well, the negative part there, then yes, it still adheres to the fact that it's a function because it passes the vertical line test. Okay, cutting the vertical line at 1 point only. So how can we restrict the inverse function so that the inverse becomes a function? Firstly, restrict the domain of M, so it's original. So it's either I take this part into account, which will result in that inverse being a function. Yes, then it passes the vertical line test. Okay? Or, on the other hand, if we take that arm of the parabola and its inverse, which is that one, okay, again, the inverse will pass the vertical line test. Okay? So how do you answer that? We simply say x has to be less than and equal to 0, or x must be greater than or equal to 0. Okay. And then the next question says, determine the equation of the inverse function in the form. So now the equation of m of x is negative 2x squared. Okay. So m of x is equal to negative 2x squared. So what we do for the inverse function, we interchange x and y. So we have y, remember m of x is your y. Yeah? So we say we interchange x and y with the inverse. So it will simply be x is equal to negative 2y squared. So I need to make y the subject of the formula, so I divide both sides by negative 2. So we have y squared is equal to negative a half x. How do we get y on its own? I take the square root thereof. If I take the square root, I must not forget plus minus. So the square root of negative a half x. But I'm sure some of you are saying now, you can't take a square root of a negative number. Not so? You're absolutely correct. But when will this be positive? If x is negative. So, then there's a condition here that x has to be less than or equal to 0. Okay, and as you can see, the graph here is where x is only less than 0. Can you see that? Okay. And then 2.5, we need that, but I don't think we need the graph for it. So if you look at 2.5, let's put this here. Question 2.5 says, write down the range of b if b of x is equal to m into x minus 2 plus 1. So the question you must ask yourself, what is the range of m of x? What's the range of m of x? People, what is range? Range of all possible y values. So what is your range of m of x as it stands here? Y is less than or equal to 0. Not so? So, what effect does this negative 2 have on the graph? The x minus 2. The graph is moving 2 units to the right. Okay. So if I move this graph 2 units to the right, then the graph will lie here. Not so? At 2. So what's the range of that graph? Y is still less than or equal to 2. To 0, sorry. Not so? So what effect does that plus 1 have on the graph? This graph is going to move 1 unit up to this point here, which is 2 and 1. So what's the range of that graph now? Y must be less than and equal to 1. Y has to be less than equal to 1. And the last question here of the cycle test of 2020 was, determine the value of a if a is equal to, now a is equal to m of 4. But remember, m of x was negative 2x squared, not so? So m of 4, wherever I see x, I put a 4. Not so? That would simply be, this is functional notation, grade 10. If you have a problem with that, refer to the video with grade 10 graphs, okay? There's going to be negative 2 into 4 squared. So that is that part. Can you see that, people? Plus. Now your inverse function for m was, what was that function again? It was plus minus the square root of negative of x. Is that correct? So if I say that the 2 is that 2 there, times plus minus the square root of negative a half times x is what? Negative a half. It's coming from here. Right? Minus 4 to the 0. And what's 4 to the 0? 4 to the 0 is 1. Anything to the power 0 is 1. Okay. So let's just simplify this. 4 squared is 16. So it's negative 32. Not so? Plus 2 times. Now negative half times negative half is positive a quarter. Not so? So it's plus minus the square root of a quarter minus 1. So negative 32 minus 1 is negative 33. Not so? Plus 2 into plus minus 1 over 2. Not so? So this will now be negative 33 plus or minus 2 times half is 1. So of course that would simply be negative 33 minus 1 is negative 34. Or when it's positive, x is equal to negative 33 plus 1 is negative 32. Okay? Is that correct? Any confusion here? Yes, many? So we didn't do the section of work. But hopefully later on when you're writing on the section, you can refer back to see this section which is functions and inverse functions for the grade 12 syllabus. Stop the video at this point.